Hi, this is Professor Ramakrishna and welcome to my YouTube channel Archiversity. In this lecture, I am going to explain you the concept of geometric mean, the formula to calculate a geometric mean. There are two different formulas to calculate geometric mean. I am going to explain you those two formulas with examples. Then we also focus on the limitations and the application of a geometric mean. Now I'll take you to my OneNote where I explain you the concept in more detail. The geometric mean is one of the measures of a central tendency. Like we have different measures of central tendency like arithmetic mean, median, mode, etc. and harmonic mean. Likewise, geometric mean is also one measure of a central tendency, and it measures the average or mean of your data series. So suppose you have a data series of a 2, 10, 15, 25, 30 like this. So in this data series, it will calculate the average or a mean. Now the geometric mean is calculated as an nth root of a product of a values. So let us say you have a product of values like x is your data series. So x1 is 1, x2 is another variable, x3 and x4 is the data time points. Then first it calculates the product, that is x1 times x2 times x3 times x4. Then it takes its nth root. So here we have four observations, 1, 2, 3, 4. So fourth root, that is n is a 4. Fourth root is your geometric mean. So here in geometric mean, this is a product or a multiplication. Now the geometric mean is different from arithmetic mean, because in arithmetic mean it is calculated by adding the numbers. So suppose in arithmetic mean, assuming that you have the same four data series like x1, x2, x3, x4, then your arithmetic mean is calculated as sum of these numbers, that is x1 plus x2 plus x3 plus x4 upon n, that is a 4. So this is a arithmetic mean, whereas your geometric mean is a product, that is a multiplication, and arithmetic mean is calculated using the sum of the numbers in your data series. So this is the difference between calculating of a geometric mean and arithmetic mean. Now we look at the formulas to calculate geometric mean. There are two formulas to calculate a geometric mean. One is the nth root of your product. So here you are x1, x2, x3 to xn and its nth root. Then you can also calculate a geometric mean with the help of a log. So first you have to convert your numbers into log, then calculate the anti-log so that you will get your geometric mean. Now I'll show you these with two examples. Now in case of a first one, we calculate the geometric mean using a nth root. So nth root of x1 times x2 times x3 likewise. Or alternatively, you can do this as a summation of x1 to the power of 1 by n. So this way also you can calculate. So here first what is that we do is we have a series here, and first we calculate their product, that is 18 times 13 times 10 times 7 times 11 times 18. So this is the product. Now for this product we calculate the geometric mean. So that is, how many observations we have? We have a 6 observation, that is 1 by 6. So 0.1667, then 3243,240, then rise to the power of 0.1667. So your geometric mean is 12.17. So what is that we did here? First we calculated the product, and then we calculated the nth root or 1 upon n. So n here is, we have a 6 observations like 1, 2, 3, 4, 5, 6 observations. Then we use the equation. So instead of this equation, I preferred this one. So this is easy to calculate. Both are the same only. Instead of calculating nth root, this will be a very easy to calculate. So your geometric mean is 12.17. Now we have a second data series. So in this data series we use a log transformation and from log to anti-log. So to get our geometric mean. So first we calculate the log for these numbers. So our log values are, so you have a log, then number is 13, then log number 10, then your log number 7, then log 5, then you have a log of 9, then you have a log of 18, then log of 28. So in the step 1, what is that we need to do? We have to calculate the log series or log values of your time series. So we calculated the log series. Then we have to sum, that is a total of these. So summation of your log x. So here you can see the equation. So first you need to calculate the log of x1, x2, x3, x4, then summation of log, then upon n. So first we calculate the summation. Now here our summation is, we'll take up to 2 decimals. So 2.57 plus 2.30 plus 1.95 plus 1.61 plus 2.20 plus 2.90 plus 3.33. So we get all the 1, 2, 3, 4, 5, 6, 7 days. All right. So 3, 3, 6 and 7. We have a 7. Then so you have a 16.86 is the value, sum of all this. Then you have to divide this by your n. That is 16.86 upon our n is 7. Now 2.406. Now this is your summation of log of x upon n. And now we calculate the anti-log of this, anti-log of our number. So your anti-log is exponential of log of x upon n. So your exponential value, this equals to 2.71823, or we take 2.7183 and we'll consider this value. So our anti-log value is 2.7183 upon 2.4086. So this gives you a geometric mean of, your geometric mean here is 11.1186. So this is not exactly the one, this is an approximate one, because here if you look at, we consider the values up to only 2 decimals. So we have zeroed off or close to 2 decimals only. So because of which our average of log of xn will be inflated, and because of which your geometric mean will be inflated. To get a more accurate, it is preferable to use MS Excel to get the geometric mean log value. Now, what are the limitations or of a geometric mean and applications? So application of geometric mean is in calculating of finance, in calculating of stock returns, we use a geometric mean instead of arithmetic mean. And while calculating annual return on investment portfolio, also we use a geometric mean. And most importantly, we use geometric mean to calculate our CAGR, that is a compounded annual growth rate. But the disadvantage of a geometric mean is that, so geometric mean can be easily calculated when your numbers are positive and doesn't contain any zeros, that is no zeros are there in your data series. So in this case, your geometric mean using these two equations are appropriate. Now what if your data has got a negative numbers or negative returns and zero values? So then using this equation you will not be able to calculate the geometric mean. For that purpose we have to use a different equation. Because when you are calculating a stock index returns or annual returns of percentage or CAGR, there is every possibility that you will have both positive and negative numbers or negative returns in your series. So in such a scenario, calculating a geometric mean using these two equations may not yield you a appropriate result. For that purpose, what is it you have to do is you have to use a different equation where negative numbers and zero values are considered. So in my next lecture, I am going to explain you how to calculate a geometric mean with the zero values and negative numbers. Keep watching, and there are hundreds of videos on Archiversity YouTube channel. You can also visit Archiversity website, where from you can download the PDFs where direct links for hundreds of finance and management related video lectures are available. Thank you. Have a great day.